All right, let's get started. This webinar was created for the Morningstar community and subscribers of oil and gas technology. This is Mark McHenry. I'll be your moderator for today's session. We'll be recording this broadcast and emailing you a link to the recording before the end of day tomorrow. During the webinar, please text any questions in the questions chat on your GoToWebinar console. We'll address them at the end of the presentation. And let's take a look at the handouts that we've included. So if we can go to the next slide, we've included several handouts for you. You can access them by clicking on handouts on your GoToWebinar pane. I suggest you download them now. That includes a copy of today's presentation, an application brief about solar power for the digital oil field, a solar-powered industrial systems guide, and a document that has links to 11 case studies. And let's go ahead and take a look at the presenter for today. So today we have Brad Burwald, Senior Product Manager with Morningstar. Brad, you can go ahead and unmute yourself and go ahead with the presentation.
Okay, thanks very much, Mark. And again, very glad to be here and participate in the presentation today with oil and gas technology. So the agenda for today is, of course, a little bit about Morningstar, who we are and the markets we serve and our history in the various industries. How and where the solar application is used in oil and gas. We'll be talking a little bit about components, mostly our products, charge controllers and other accessories. Hazardous locations themselves in terms of the classification, the ratings and the markings that are on our products that allow them to be used in these applications. We'll go into a little bit of detail there. And then also a little bit of details on remote monitoring and data. Obviously the SCADA application for oil and gas is a very big one in terms of collecting information, not only about the pipelines, but also about the power systems. That's where our products come in. So we'll be talking a little bit about that. And we also have several case studies that we'd like to go over to show you some of the examples of just some of the solutions that can be, solar controllers and solar systems in general can be used to solve in the industry. And then lastly, questions and answers. Of course, we'll be covering a lot of info, so we want to hear from the participants and hopefully give you some good information after the presentation. So again, as Mark had introduced me, I've been with Morningstar for about 20 years now, currently in a senior product management role and really doing a lot of the design and creation of the products and the markets that we're accessing with our controllers. And I've also spent time in sales and in technical support over the years. So with that, I will go ahead and get started. So first, let's get going with a poll question, and I will go ahead and launch this in the software here. So you should have the ability to see that poll question right now. So if everyone that's participating would like to click, I think you can give multiple answers. So if you're serving multiple markets, we'd like to know, where are you deploying or using solar power to power loads at your oil and gas sites? Just because we're looking for some feedback, and it would be interesting to the rest of the audience just where around the world a lot of these installations are taking place. And as you'll see in our presentation, we're covering both offshore oil platforms as well as pipelines, possibly in very remote locations across the desert. So this feedback would be really useful. Okay, I'll give just a few more minutes. If you haven't got a chance, please get your response in there, and then I will go ahead and close the poll. Okay, I think in looking at the feedback there, a little bit in Africa and the Middle East. Let's see if I close the poll. I think we'll get the results. Okay, about 8% Africa, Middle East, 25% Asia, Australia, and New Zealand. That's quite interesting. We know there's some very specific focus in the Southeast Asia region. 67% in North America as expected, very large market here, and 8% represented in South America. Okay, there you can see the results on the screen. Okay, thanks very much, everyone. And I will go ahead and resume the presentation. So thanks for that. So a little bit about Morningstar. Morningstar has been around since 1993, and throughout that time in the industry, we have over 4 million products deployed into the field across our product line. Our products have been sold in over 100 countries and are typically used for mission critical solar applications. So these would be industrial where, you know, the failure of that product is really not acceptable, and they need the best in reliability because it's in a distant location, a hard to reach location. Mountaintops are a very common site for a lot of our systems, and we build the products to make sure that the confidence is there for that reliability. We think of ourselves as the charging experts. We've got a very diversified product line, not only different power capacities and feature sets, but some very application specific, for instance, solar lighting, or what we're talking about today, which is hazardous location installations. Having the lowest hardware failure rate in the industry, you know, proven by our track record and our, you know, failure rate analysis, because we've got to keep that, you know, we want to stay at the top of the quality spectrum. And we serve a lot of industries, including oil and gas. Telecommunications is another quite big one for us. Security systems, solar lighting, and other areas would be commercial solar. We do serve also mobile and marine markets as well for, you know, RVs or boats or mobile applications, some military, and then of course residential and rural electrification. One of the largest projects of note that I wanted to bring up was we completed a couple years back one of the largest residential off-grid projects in the world, and it was an installation that took place over about 18 months throughout the country of Peru. And in the end, we had electrified over 200,000 homes, 3,000 community centers that featured medical and other types of office equipment power, and in the end, reached over 1 million people in the country of Peru. So we're very proud about that application. So moving on, solar is an extremely well-established power solution for oil and gas. It's been used for decades. It was already a strong market when I joined Morningstar, and it continues to be till this day. That's because of the very efficient, you know, solar generation, and we've been able to grow with the efficiencies of the solar modules themselves. As they improve and our products improve, the power systems become more reliable. They get used in more applications, and I would say that the loads that they can power are obviously increasing in size over the years. Because they're DC native, it's an excellent resource for automation and control systems, and they can also be integrated into existing SCADA systems, that system control and data acquisition, and that allows both power as well as the automation systems to be combined in terms of how they're managed. We provide power in 12, 24, and 48 volt systems, and most importantly, the solar controller can work in parallel along with other charging sources often used in this industry. That could be thermoelectric generators, fuel cells increasing in popularity and capability, and also AC and DC generators continue to be used for a lot of these applications. So when you combine those systems into a hybrid system, solar plus another charging source, you gain even better reliability and diversity with the energy supply. So that's an important part of our application. In terms of where we fit in the industry, I'm sure everyone is familiar with upstream, midstream, and downstream components of the application that we're talking about today. Morningstar is largely involved in upstream and midstream. So in the upstream side, in terms of the actual, you know, production or collection of the resource, you know, whether it be offshore or through wellheads throughout, you know, parts of Texas, that is a big user of solar applications. And then in the midstream side, in terms of the aggregation, the transport, and the monitoring of, you know, that resource, whether it's going through oil and gas transfer equipment, there's asset monitoring, flow management, other safety and processing that takes place, all the way to transport. We're also taking a very big role in that step in the industry as well. And off-grid is really the most reliable and practical of you know, ways to power these systems, because if you look at it compared to not just other energy sources, but even other renewable energy sources such as wind, it's just the simplest overall and the best fit for the types of power levels that you typically see. And you'll see a lot of example photos as we go through the case studies, and that will help to really, you know, fill in the big picture there for everyone in attendance on, you know, where our products are used. You know, new moving parts, you know, little to any maintenance is not required. Any kind of tear down or rebuilding of, say, something like a genset or a mechanical application is not required. There's no need to visit the site because, you know, the fuel is the sun and it comes every day. Integrates easily with, you know, existing energy storage, and really, you know, in an application where fossil fuel consumption is the goal of the industry, it does integrate a certain level of green oil field objectives by incorporating renewable energy into these production systems. And then, of course, whether it's the desert or Arctic conditions, our products have been proven in a wide variety of installations and environments. So that's also a big point of the solar application. So in terms of the size of the systems, just to give a little bit of a flavor for the applications, you can see on the left in our small and medium size, which is by far the largest application, remote terminal units, PLCs, HMIs, other types of interfaces that cover input and output for an automation site, flow and tank level measurement. All of these can be easily powered by solar because they're really just integrated digital computer systems. We can actually get into applications where there's certain valve control taking place, actuators, solenoids, where we can take action at a site in order to divert or turn off a valve. That's very important, especially for safety considerations and emergency shutoffs. And then also security is being a bigger and bigger part of the industry, not just to get eyes on the site for, making sure that no one is inside the fence, but security cameras, especially with a lot of artificial intelligence, can actually look for abnormal conditions at the site, such as visual distortion from leaks, obviously fire, or other things that can take place. So security is also a growing application. On the larger side, again, solar being extremely reliable can work with gensets in a hybrid application, but we're seeing a specific move to even more 100% exclusively solar powered sites with pretty substantially sized arrays, in the number of kilowatts, and they can easily handle several 100 watts of load 24/7. And these would be applications such as cathodic protection to mitigate against rust and corrosion of a pipeline, injection valves that are actually putting freeze inhibiting materials and substances into the pipelines. Pumps and motors can also be driven by DC or even AC with an inverter. And then of course UPS and backup power. So maybe not exclusively an off-grid application, but by adding solar, it becomes an additional layer of backup for a critical application. So just a few examples of some types of applications. Here's a measurement and automation system that was deployed. This is at a point behind the fence here where there's a lot of interconnection. And in this case, uptime is critical because there's assets being managed and monitored. So that's, equates to money, and therefore needs to be accurate and up at all times. And the benefit of these systems, as you can see inside the fence here and very near to the pipelines, is that they are hazardous zone rated, which is a big part of our discussion today, so that they can be installed right next to the equipment, sometimes even on the pipelines themselves, depending on the size. And this was a system put together by SolarCraft, an integrating partner of ours and powered by Morningstar controllers. Of course, offshore, this is a really specific application where hazardous location is a must because there is no ability to put the system outside of the zone. The zone is the platform. Everything on it is designed to be, hazardous location rated, and therefore meets a higher degree of engineering standard. Obviously, a lot of these sites are autonomous, they're unmanned, so therefore the reliable power is really critical. And it's very interesting applications here because in addition to the ones I mentioned on the previous slide, when you're offshore, you get a whole new list of potential uses, such as foghorns or navigation aids, for nearby boats. Communications, sometimes by satellite, is often a big requirement for these platforms. And an interesting one, if you've ever seen a laser bird deterrent, also very critical because long term, that's something they also want to mitigate, is the birds. So in this case, it was JCE Energy provided us this photo for this application. And then also mining operations. In the case of mines, a little bit different in terms of needs for their safety and ratings, but is a big user of solar. And what's interesting with mines is that a lot of times the applications tend to change. As the mine is developed, there's movement of the equipment because they're, depleting the resources. There's different mining applications where you may need to move equipment around. There's some autonomous vehicles sometimes in use, especially like I've seen in Australia, where the equipment requires constant mesh communications network to keep everything online. And trailers such as this one can be deployed and reused, which reduces CapEx costs and also, still meets the needs of the system. So a little bit about charge controllers, which is mostly what I've been talking about being integrated into these systems. They are the heart and brains of off-grid solar. So when you have your PV module and your battery, the solar controller is in the middle, so it sees all the power coming in and out. It's able to monitor, the status of the load, PV generation, battery capacity. It detects, alarms and faults, and it provides extensively collected data on all these pieces of information and can share them out or store them for later retrieval. So the charge controller is a really critical part of the application, and you want to make sure that the right choice is made for battery type, because the controller and its job should be to provide many years of reliable service from that battery through proper charging and discharge protection. Okay. And in some cases, when there are a need for DC loads, they can be connected to the controller, and we can also provide AC systems as well for larger loads. Pumps and other applications typically prefer AC, and we have a line of inverters as well that can cover that. So now to get into a little bit about the HazLocation certifications, we'll be talking about some of the testing laboratories that are used and their associated marks. So here's the big three that I imagine everyone in this industry is familiar with, and that would be Intertek, in this case IEC, Explosive Division, and ATEX. Okay, the familiar logos on the products that tell you that the products are adequately rated. And Morningstar's products that are listed for both IECEx and ATEX, as well as the North American standards for Canada and the United States, which are covered by Intertek, are on our primary product line here, represented by our Sunsaver and Sunsaver MPPT, as well as our ProStar products, the ProStar and ProStar MPPT. And the certifications are pretty broad in terms of what they cover. Different products have different markings, and I'll just be going over a little bit of the labs here first to kind of set the groundwork, and then we'll be getting into more detail with what products have what ratings and where they can be used around the world. So UL, of course, Underwriters Laboratories, and along with that certification in North America, we also get the CSA standard for Canada, because it has an equally large application for hazardous locations in the shale fields and those in the West. IECEx is really the biggest international facing. We use this for not only our safety and protection certifications for our controllers in other markets for just human safety, but also for the EX division for hazardous locations. And then ATEX is specifically focused around the European Union. You will see that the UK is going to be providing a standard that's separate from that in the near future, which we're monitoring closely and expect to also have deployed. But for now, ATEX is the hazardous location certification on record for most of the EU. So to talk a little bit about the hazardous locations themselves, this is probably the most important point to make, is that there are terms like explosion proof and intrinsically rated, and I'll talk a little bit about those, but the biggest theme for all of our products is represented here, in that these are class 1, division 2, which is how UL and CSA rate the products. And then with ATEX and IECEx, they use something called a zone system. So despite division or zone, what it really comes down to is that the products are rated to provide safe operation and not cause an explosive event during normal operation in an environment where explosive materials are not normally present, but could be present. Okay, so in other words, these are not surrounded, inside a tank, surrounded by an explosive environment. They are in an area where if there was a leak or a malfunction, those gases could be present, and therefore the product needs to be suitably rated to not cause any kind of an explosion. Okay, so they are rated for that. And the groups, if you want to get into the specific chemistry of the gases provided, that information is also available. But yeah, that is the key with all these products, whether it's a zone or division classification. When everything is operating normally, they will not cause an explosion through the reduction of energy in the product in terms of how it's sealed. The energy levels used are below a certain threshold. There's not going to be any kind of sparking, arcing relays that would click and cause a spark and could cause something to combust. So in this case, the class 1 is gas and vapor, and then as I said, for North America, it's a division 2 rating. and there's a zone 2 rating for the EU and for international. There are other degrees where they may be actually explosion proof, and you can see those listed here. Where our products fall is highlighted there on the right side. So to get into a little bit of a breakdown of specifically what this means, our products have a specific label on them, and you can see them on the certifications from the labs, which can be provided, of course, if needed, so that you can really see exactly where they fit in. And if you look there at the top, that's an example of how the breakdown of these ratings occurs. And then what I'll do is cover on the bottom where we specifically fall. So in this case, the gas zones, this would be zone 2, where explosive atmosphere is unlikely to occur under normal conditions, and that's for normal operation. Gas groups, this would be groups 2A and 2B plus acetylene and hydrogen, so that it's based on the chemistry and how volatile they are, but that is the ranking of the gas products that can be in these environments. And then further down, you can see what is the actual protection concept. There's a variety, they can be vacuum sealed, they could be explosion proof, flame proof, they could have flame arresters intact. What we specifically have here is what's called increased safety and intrinsic safety. And that means that the product has been sealed and designed in such a way that it will not cause any kinds of these ignitions to take place during normal operation. And with intrinsic safety, it means that any kind of switches, connectors, button presses, anything that may cause an energy discharge to occur is below an intrinsic level that would cause an ignition. Okay, so that's what intrinsic and increased safety is. Group 2 is actually classified for the electrical equipment, for use. That's kind of what the charge controller actually is. And then lastly is the temperature class. So typically you'll see T4 or T5 with their associated temperatures in degrees Celsius, and that basically means they are not going to exceed those temperatures, during any kind of normal operation, that we're below that point. So that talks about what temperatures they can be used in. Okay, so that's a bit of an overview. And just to kind of summarize here, what hazardous location certification actually does is, prevents this from occurring, because if you've got a flammable substance, you have an ignition source, which could be our product, but would not be because it's not rated to cause that, and an oxidizer, you can actually cause an explosion. And the three primary ways to prevent something like that occurring are to isolate the product, seal it in a vacuum, put it in a container where an explosion could occur, but would actually be insulated and enclosed in that housing so that it doesn't spread to the rest of the site. And you'll see some examples of some explosion-proof equipment later on in the presentation. And then the third is intrinsic safety. That's the last way to prevent this, and that's what our products fall under, is intrinsic safety ratings. So a little bit about our products here for a quick overview. The products that have been in the industry longest, which we'll kind of feature on, and they've gone through many generational updates and improvements, and most recently these new enhancements. One is the Sunsaver PWM. This will be a pulse width modulation controller, and it is basically a 6 to 20 amp rated product. It has built-in self-diagnostics, completely passively cooled, no cooling fans or moving parts or relays in any of our products. And you'll see from the cutaway here that it's completely sealed in an epoxy encapsulation, and that keeps the circuit board completely isolated from the environment, as well as provides very good heat conductivity so that it can reach 60 C ambient ratings. And of course, everything about it is designed for a hazardous location. And then you'll see that the Sunsaver also comes in an MPPT variation. And MPPT is maximum power point tracking, which is a little more advanced design in terms of power generation and efficiency, and works with a wider variety of solar modules. Okay, and you can obviously read about PWM and MPPT in terms of which products it relates to on Morningstar's website for more information. So this industrial grade design, which covers both of these products, is really the biggest contributor towards its success in oil and gas. Generally, these are for 400 watt peak solar systems or below. We also, do not provide any kind of, ingress opportunities for products, because, as I said, they are completely sealed. Another featured product we have that also meets these ratings is the Sunkeeper. It is ETL listed for HazLoc in North America, and it was actually designed to be integrated directly into the solar module itself, in the junction box, which is why it's got that unique design there with our conduit fitting there on the end. And that's very common in applications that do not need load control. So this is a good overall slide that gives an example of the complete line, the ProStar MPPTs, the ProStar PWMs, the Sunsaver family I just discussed, and the Sunkeeper. And this covers the certifications that they have. You can see below there's the specific details of the zone and gas and class ratings for each of the products, whether it be IECEx or ATEX, and then of course our UL and CSA listings. So definitely a good reference for a lot of these products. And you'll find that on our website we have these authorizations to mark the products from the labs available, so you can get these specific details. It's a really great document to have in hand when you're doing perhaps your own system integration or you're deploying these controllers in the field, because it gives you that confidence that you've not only got the test certificate in hand, but also the product has the marking right on the cover. Another product that we have in a higher power class is our Tristar family, and that also comes in both MPPT and PWM. And this is a great example of a explosion-proof housing. You can see from the thick walls and the many bolts that this product is actually integrated into an explosion-proof environment, explosion-proof housing, for use in a higher rated environment, and is also a product that gets a lot of traction in HazLoc. And because of its high power rating, 3 kilowatts per controller, and these can also be paralleled, 3, 6, 9, 12 kilowatts of total power if you want to scale the system to be very large, and it can easily run loads of several hundred amps, 24 hours a day with several days of standalone autonomy. And again, very popular here for telecommunication systems, large cathodic protection systems, or those that have mechanical power such as load actuators, injection pumps, things that are not just RTUs. Here's another example of that explosion-proof housing. And what's important to talk about here is that we also have a variety of accessories. Probably could be covered in a presentation all their own because it gets into different types of serial Modbus communications and other standards. But the point I wanted to make here is that all of these accessories, whether it's serial converters or our Ethernet adapter or our relay accessories that provide additional system control, all of these accessories have been integrated into the testing plan for the host products that they work with when the hazardous location certification was completed. So if you have a solar controller such as our ProStar MPPT, you wish to deploy it into these hazardous zones, and you want to actually provide Ethernet capability, because in the digital oil field applications we're seeing now in 2021, Ethernet and Modbus over IP and switches, routers, wireless connectivity at these sites, it's growing immensely. There's a big need for data, and therefore these products are often used to provide that connectivity. These products and these accessories can be used together in the hazardous location zone because they are all part of the same test plan. So I just wanted to give everyone that confidence that they can integrate all the continuous products that they've been using. So why would you use a lot of these systems to integrate? Well, I'll provide just a little bit of background here on data. We support a variety of standards, and as I said, in both telecom and oil and gas, maybe even in some residential systems, customers want data remotely. It's just the standard. They are in hard to reach locations. We've got the wireless capabilities now between satellite and 5G coming, and a variety of ways to reach the sites at lower and lower prices every year. They do not want to have to send a helicopter to that mountaintop site. So getting it connected is the best way to keep eye on it and also to be able to control it in some cases. So in this case, we support Modbus RTU as well as packet-based Modbus over IP. And we also support SNMP. That's a protocol more specific for perhaps telecommunications and IT systems, but we do see quite a bit of overlap because, to be honest, a lot of oil gas is becoming very IT and telecom centric. It's kind of a combination. So we make these protocols open. They can be integrated. In cases, we've worked with many partners such as Zabbix and others in network management systems. We've been supported by a lot of cloud HMI systems that use SCADA for Modbus IP, and we provide a lot of support for those integrations. So feel free to reach out to us about that. And all of our products listed here, do have, in the case of the ProStar family, data connectivity options with those accessories. The only ones that do not have data connectivity would be the most smallest, such as the Sunkeeper. So just wanted to make a particular note. We have a variety of really high quality documentation online that gives an example for many of the applications that we support. I'll be covering some of them here, but just want to make sure that everyone's aware that a lot of our oil and gas case studies that feature solar and a variety of applications are available on Morningstar's website. You can see the link there at the bottom, and I would encourage you to take a visit, and we'll be covering a few here today, as well as the assets that are attached to the handouts section of this webinar. So some examples of the many applications. So in this case, this was in Eagleford in Texas. It was a shale site, and this was an installation that you can see has a sizable array and battery bank, integrated Morningstar's Tristar and Sunsaver solar controllers. These were hazardous locations. As you can see, the pipelines just overhead and on the right. And this was completed by one of our integrating partners, Ameresco Solar, utilizing Deca solar batteries, a very common combination, and it was providing SCADA data for RTUs and for cathodic protection. And you can see a lot of our products are used in parallel, large controllers for, major PLC equipment, and sometimes RTU systems, just a couple dozen feet away, utilizing the Sunsaver. So the systems are actually autonomous. On a very different application, the JCE Energy installation here in the North Sea was a unmanned oil platform, and they needed power, of course, for the navigational aids, excuse me, bird deterrent systems, and of course, with the salt spray, the remote location, a lot of money just to visit the site with a manned team. So they want the utmost in reliability, and the designs are such that they can easily be maintained remotely. We can collect data from the system, and they've proven themselves over the decades as being a very reliable partner for these applications. In this case, this is a small natural gas transfer site here. Just a little bit of safety monitoring, a very modest array, and the Sunsaver 10. Again, these are very small systems, but typically deployed in very large volume, and really it gave them ability to get points of measurement along the pipeline over many hundreds of miles in terms of what's happening with the systems. Here's another offshore unmanned platform. This is in Southeast Asia, actually in the Gulf of Thailand. And the partner here was Orga BV and PTTEP, excuse me. And this application was actually to power helideck lighting and some marine and navigational aids. Another installation that type of application that Morningstar has done a lot of is these very important, safety lighting systems. And this is both for, navigation in marine environments. And you might be interested to know, in a lot of tower applications, we provide a lot of aviation obstruction lighting at the top of a tower. Both of those are really good applications for solar, and it's required for navigational requirements as well as by the FAA. So it's an absolute safety requirement, and we can make that very easy to provide, especially with the technology with LED lighting, a very safe, economical, and reliable application for lighting. In this case, the Tristar was the product that was used, and one of the benefits here, again, the explosion-proof housings there in the bottom right, the Tristar has not only the data logging capabilities, but the ability to provide remote reset and control of the device from, at distance, or to be honest, anywhere in the world, because of that IP connectivity. So therefore, that's why that product was chosen, because of the reliability and also the control application. Here's another application by JCE Energy, and in conjunction with the Kuwait Oil Company. And this was based in Dubai in the UAE. And this was actually for oil field lighting systems. So you could see in the bottom left there, there's a variety of pieces to this application, but one of the most important was for safety and security of these sites. You can see in the bottom left there with the razor wire around the fenced-in enclosure, there's pretty significant presence of solar PV, and the Tristar products were chosen to provide that lighting. And we've seen a very large increase in lighting in a variety of applications. Could be street lighting, could be for safety in this case, or even for other types of security elimination in other industries. And that's been driven a lot by, of course, LED technology because of the costs. And LEDs are natively a DC light, so it's a perfect choice for solar. Here's another offshore application. This in Brunei in Southeast Asia, and a very interesting helideck illumination program here that was providing safety so that they can land. Many of these are 24/7 operations, so obviously this type of lighting is critical, and they don't want to have any impairment of, to get to the site. If it were to lose power, you would actually lose illumination, so it would provide a hazard to anyone that was trying to actually get to the site. Therefore, a lot of these lighting systems are on autonomous power systems, such as solar, and potentially, segmented from other systems for that redundancy and reliability. Here is a application by an excellent integrating partner, SolarCraft, and this was deployed in both Texas and Colorado. You can see a lot of times these are deployed at scale, and they're put on skids with the enclosure and the solar array integrated. Here, the solar array actually provides some much needed shade, as well as the proper tilt for optimal power generation. And these can just be dropped in place, ready to go, with the vertical battery installation there and the Tristar MPPTs actually located at the top of the system. In the bottom right, you can see, I know it's a bit of a strain to maybe see all the system components, but if I could just point a few things out, you can see a variety of SCADA, Ethernet, communication equipment, as well as an inverter. So this product is actually a mixed DC and AC system combined into a single enclosure. So that's the type of system integration you often see with these products. And then lastly, another JCE Energy application, and this is a hazardous location installation as well. You can see, very tight constraints there. One of the interesting things with when Morningstar gets involved in projects of these types is we have really high quality support team and applications engineering team. And because these products are, engineered for these applications, we have detailed documentation and support capabilities to provide efficiency and enclosure design data so that you can get a very exact amount of heat calculation for enclosures just like this. So we can make sure that given the amount of space in the enclosure, that the system is going to be reliable, it's going to meet the needs of the hazardous location requirement, and we're happy to provide support and engineering assistance on designs such as this. And in this case, very high power loads, a 25 kilowatt system made up of several of these enclosures. The load itself was 1.6 kilowatt continuous. That's very significant for a solar system, and with a 5,500 amp hour 24 volt NiCad battery bank. NiCads being a very specific chemistry, which we can support in our controllers, and they're often used for, they're quite pricey, but they meet the needs of systems where they need extreme long life, very good reliability, and of course, the cycle life on NiCads is significantly better than lead acid. So we'll see very specialized chemistries such as this in these applications. Here is an installation with Swift Energy and Honeywell. In this case, this is a dry dock installation. A dry dock application where this has yet to actually go out to sea, and I think it's quite impressive to see what really makes up, these floating oil platforms. In this case, this was actually installed with a Honeywell. You can see the automation and control systems down there on the left. Also used Morningstar's Tristar MPPT. And this is a shot from the shipyard, which I think is pretty rare and quite interesting to see. And in this application, a lot of these sites are communicating with satellite connectivity to, get the data, because they are many, many miles offshore. One additional application here is with our partner Connexa, and they utilized Relion, which is actually a lithium ion battery. That's a chemistry we're starting to see supported more and more, and a lot of the products that I've discussed today do have the capability to support lithium ion batteries. And in this installation, it actually is in Chile's Atacama Desert, where you're going to see extreme temperatures as well as salt air because of its presence near the coast. So you've got two extreme environmental factors working against you, but we've got proven reliability in these applications. And this actually involved 54, stainless steel skids that were deployed and set up extremely quickly because they were all pre-produced, integrated, and designed and deployed rapidly into the field. And Relion is actually, as I said, a lithium battery, and integrated into our products due to a lot of the work done by our energy storage partner program, which helps us to provide manufacturer-specific certifications on battery compatibility. And a lot of that is done up front by our engineering and applications teams in conjunction with the battery. And companies like Connexa really rely on that because it gives them that peace of mind that the design has been, predetermined to be, fully suitable for the application. Lastly, in this case, a polar power expert, Tracy Dahl, gave us some information on this site. Again, something else very unique, and these are actually LiDAR and radar stations that are providing weather monitoring for remote research. And again, in this case, you would see a few unique application attributes. One is extreme cold temperatures, and the other is that a lot of these sites are actually much higher, north, to put it lightly, and therefore you will see a very specific application for the Sunsaver PWM because the solar module is at a very high degree of tilt because the sun is very low in the sky because of the fact that it's at such a high position on Earth. You've got to change the tilt angle of the PV. So design aspects such as these are obviously unique ones and ones that we work out with a lot of our integrating partners to make sure they have a reliable solution. And this was actually chosen to completely replace diesel generators that were previously being used in these installations. And then another application here, offshore, is Tideland Signal in conjunction with Marlec, a company in the UK, and with Shell, who we're all familiar with. And these are also normally unmanned stations that have gone to solar completely after years of using diesel generators. And you can imagine between the maintenance and the generator, runtime, the fact that they need to be rebuilt over many years, and the sites need to be visited, as well as the fact that you've got to get fuel to the sites in a very challenging location. This really transformed these sites to be completely solar powered. So, okay, so that is a pretty broad overview of a lot of the case studies and examples of a lot of these applications. And just a few other pieces of information to share. Morningstar has provided an industrial solar guide, which you'll see a lot of these systems featured in the case studies, as well as direct tie-ins to the products that are used in those case studies. And that this industrial guide gives a lot of examples, as well as some design guidance. And you can see the hazardous location details that I talked about, which is an excellent design aid. And this industrial solar guide can be found on our website at the link above. And then lastly, our application brief, solar powering the digital oil field, gives a bit of an overview of where the oil field, modernization has taken place. As I said, we've been in the industry. It was one of the first applications we addressed in 1995 when our first products came to market, but it's one that's been in existence for decades. And as it's transformed over the years in terms of using more solar power and renewable energy applications, as well as data connectivity, this overview kind of gives a lot of that background and draws points between these applications featuring our products. So definitely give that a read as well at the link. Okay, just to kind of finalize, you can see many of the familiar faces with Morningstar's team here. This is the majority of our sales team on hand, many of which have excellent experience in the oil and gas industry, as well as a variety of other applications around the world. And they work in close conjunction with both the product team to make sure we can address new markets and new opportunities and keep our products constantly in a state of innovation and renewal so that we're keeping up with the industry. And you'll also see that the applications team can provide that support you need for those types of integrations. Okay, so definitely feel free to reach out to us at any time on email or phone so we can make that available. Okay, and with that, that is my last slide. So thanks everyone for listening, and I would like to bring Mark back on the call, and we will take a look at some questions we have, and I'll do my best to give answers.
Sure, okay. Well, thanks, Brad, and thanks for everyone for attending. Let me just first give a shout out. We have somebody from JCE in attendance, so I want to thank them for the information they provided us for a couple of the case studies for the offshore platforms in the North Sea and the Java Sea. So thanks very much for that. We did have some questions about batteries. Let me go to them. Let's see. So the question is, what types of batteries are best for using in hot conditions versus cold conditions, lithium versus lead acid. If you can kind of cover that, and especially which ones would be best suited for oil and gas applications.
Okay, well, I'll if I can just kind of hit a few key bullets on what I would recommend to be thinking about. This could be a whole day discussion because it's you know, a lot of what we do is fitting the right battery, the right charge settings for the right design, you know, for these applications. But I'll just mention a couple things. Lead acid is an excellent you know, solution for oil and gas in terms of being fairly simple in design. No battery really likes extreme temperatures all that much, but it's more about taking care of them, charging them correctly with the proper temperature compensation, which our controllers provide, and really the environmental you know, aspects, like insulated battery cabinets are often used. Keeping those batteries full actually keeps their temperature operating range broader, especially in cold temperatures. So proper maintenance, they can definitely you know, work well in these installations. In hot temperatures, the shading that I had pointed out in that system, keeping that enclosure cool and making sure they're out of direct sunlight, not only with the enclosure, but with shielding or heat shields. Sometimes forced air ventilation has to be used, is also very important. I've even seen batteries buried in extreme hot environments. So, but in terms of chemistry, lead acid is an excellent choice still, just taking into account. Lithium in more moderate temperatures can still be a very good choice, and you'll see dramatic increases in cycle life and overall reduction in costs throughout the life of the system. And then I would say that NiCad, while a premium in costs, probably provides the best overall temperature resiliency, but you'd have to check on, you know, the design aspects and your budget. So I hope that provided a little bit of background, but I would encourage you to, you know, reach out with, you know, more specific questions. Definitely take a look at our energy storage partner program page on our website, and you'll see a variety of both lead acid and lithium and other specialized chemistries that we support.
All right, very good. Yeah, if you go to the website under our resources tab, you'll see our energy storage partner program, and there's a ton of information about a number of different lithium brands as well as lead acid brands. Kind of a follow-up question to this. Nick had a concern. He said, as I'm sure other people have read, about issues with fires and lithium batteries, and maybe you want to touch upon the difference between the lithium iron phosphate batteries and the lithium cobalt oxide batteries and other batteries.
Okay, I would say that obviously with the higher energy density, you know, and more, you know, volatility with the lithium, that, you know, there is a little more concern over some lithium batteries than compared to lead acid, which is, you know, fairly docile, I guess I'd say. But in terms of lithium iron phosphate specifically has been one that's a lot more, I would say, safe from a certain standpoint of, you know, if you have a puncture or damage to the enclosure itself, it's less volatile because it doesn't immediately, you know, have that kind of reaction with the environment and the atmosphere around it. I would say that if you look over a lot of our previous partner presentations with some of our ESP partners, you can actually hear, you know, from some of the chemistry manufacturers themselves how they feel about these types of questions, and they can provide a lot more detail. Because I would say that, you know, lithium can be used in a lot of these applications, and obviously the right set points and the right internal design with a lot of these lithium batteries having a BMS inside of them, you know, additional electronics, tries to make sure that a lot of these types of things are kept in check in terms of charging and temperature and just internal monitoring. So I would never dissuade someone from using lithium, you know, purely for that reason, but you would have to check on the safety implications of a site. So I could say that lithium has been used in oil and gas applications, but I would say lead acid is by far the most common chemistry still.
All right, very good. Fernando asked a question regarding Tristar products. In the completely sealed enclosures, is there enough ventilation or temperature transfer so as not to overheat the controllers? And I'm just going to jump in here a little bit. I remember I had a question about this, and I guess a lot of this depends on where this application is located. If it's in a cold climate and there's plenty of air circulation around that enclosure, I guess this would be, you know, there's a lot less to worry about that. But Is there anything additional you want to add to that, Brad?
Yeah,
As far as
I could
the
touch
heat?
on this. Obviously, in a lot of rural applications, like we actually did some system designs recently where there was a preference for active force cooling that was thermostatically controlled. However, to use these examples of these photos that we were talking about, it's an explosion-proof environment. It is completely sealed. Therefore, venting is not an option, passive or active. That the thing has to be completely gasketed and bolted shut. What I would say is when you get into the finer points of engineering, with our products, we have power and efficiency curves available. If we're given a specific PV capacity and the operating voltages and battery voltages, we can very accurately determine the operating point of that controller and therefore its efficiency and the amount of heat that would be generated by that product in operation. If you have the enclosure design, it really comes down to the surface area of the enclosure. And I guess bottom line is if we know what that incoming heat is and we know what that controller is able to egress out, and the egress is larger than the heat that's created inside, that design can be created reliably and still remain environmentally sealed. The numbers are behind it, and we can show that. We have support documents on that, and we can assist with that in the design. It's obviously very challenging, but that's why these designs are done by some of the the best off-grid solar engineers for these reasons. So we can provide support for that.
All right, and to Fernando's follow-up question, so it appears that he's in Mexico and he's wondering either on land or on oil rigs in the Gulf of Mexico, could that be an option for him, these enclosures? And maybe like as you said, that's something you'd have to take up with the design engineers who are putting that together.
Yeah, you just look at your needs, and I would say some things. Our products, they temperature and current limit when needed. You can actually oversize them to run even cooler just based on your engineering needs. But I have complete confidence throughout deployments we've seen in the UAE, telecommunication systems in Oman. We've definitely handled extreme environments. It just takes doing the math.
Okay, very good. I see another question here. It's going to test our conversion capabilities here. Looking at the horsepower conversions, I guess, into metric conversions. So let's see. I need information and support to provide. So we might have to refer this one to. As a matter of fact, I see we typed into here to contact our team here so we can sit down on this. But you might know the answer. I need information and support to provide off-grid power for a 20 horsepower motor. How can I get help? Is 20 horsepower in our wheelhouse? Yay or nay? Or should we kind of table this one?
My wattage to horsepower conversion escapes me right now, but I would say that is a sizable load. That is a significant load. I would say that most likely, I'm going to take a guess, is probably going to be 3-phase AC to really get the best design. I'm not saying that can't be powered off grid. It's possible, although you'd be looking at pretty significant, probably inverter capabilities, most likely in the 3-phase category to do that. Certainly Morningstar can provide all the charging capabilities, as I've seen systems, as much as 60 kilowatts of PV energy to charge the batteries. The big question is, how long does that motor run? Because you can provide power as long as it's for a very short time. I do know that we have provided some power for emergency shutoff valves that are typically in a standby application that are several horsepower that only need to be actuated in an emergency event. Therefore, they're big, but they're only run for a very short time and very rarely. So, that could be a possibility. But I would say we'd have to look at a bigger design to be able to tackle that.
Okay,
Probably a generator
good.
hybrid as well would be wise.
All right, we have a question here about elaborating on the accessories, Morningstar accessories that are used with Morningstar HazLoc products. Basically, the question is, can the accessories be used with in a HazLoc location with a Morningstar HazLoc controller?
Yeah, I'll go into greater detail. Typically, just to name a few, we have a relay accessory that provides great auxiliary relay control for various switches or dry contacts that need to take place in a system. We have several serial converters, our RSC, our MSC, our UMC, that convert from RS-232 to 485 and USB. We also have our EMC1, which is a serial to Ethernet adapter and is very popular. And that's what enables Modbus IP and SNMP, as well as other types of remote monitoring for SCADA. All those accessories at the time that these new products were updated, you know, Sunsaver, ProStar, ProStar MPPT, those accessories, all of them, were integrated into the test plans for those charge controllers. So if that charge controller is the host product that carries the certified listing, and that accessory is a, you know, certified, I'm sorry, not certified, but a compatible host accessory, when it's used with that host together, those two products, the controller and the accessory, can be used in these hazardous locations, okay? The accessories do not carry listings themselves. They're not meant to be used standalone, but when they're used with the host product that is listed, they are perfectly compatible and certified for use together. Most of these accessories don't really have a standalone application, with the exception of the relay driver. They go with the controller, okay? So I hope that provides some confidence, but yeah, any accessory you've been using, you continue to use with these controllers in these environments. It's all been taken care of with the labs.
All right, well said. It looks like I have a question here about lighting control. Okay, looks like lighting control and solar are commonly used together. Can you talk more about lighting capabilities with charge controllers? What can they do to manage lighting systems?
Okay, so a lot of the DC loads, lighting loads on the controller, we manage the PV and the DC load. So we have control over that terminal, both for preventing the battery from discharging, but in the case of lighting applications, we also have some timer-based controls. So the controllers can automatically turn the lights on, usually on a day-night transition, such as, you know, when it gets dark. They can turn them on and off a couple different times based on a multi-part schedule. They can turn them on or off a certain number of hours after sunset or a certain number of hours before sunrise for like kind of a two-stage control. And that is integrated into the Sunsaver MPPT, the ProStar PWM, and the ProStar MPPT. So we do have some degree of you know, lighting control based on dusk till dawn transitions, which is probably the vast majority. And as discussed in this presentation, you probably saw that there were actually quite a few lighting applications, even though we see a lot of rural applications and street lighting, that we're seeing an increasing number in actual oil and gas for security lighting. And in the case of mining, there's also a lot of lighting applications. Okay, so I hope that answers your question, but yeah, all three of those products provide a compatible timer-based lighting programmability.
All right, very good. I see a question here. Let's see, you mentioned solar powering cathodic protection systems. I've heard the term, but I'm not familiar with that. Can you explain a little bit about how they work?
Sure.
I have seen one of our technicians answered this, but do you want to go ahead and do that, Brad, or?
Yeah, I mean, just to give a light overview, if you're not familiar with cathodic protection, it's essentially, you know, anytime you have these extremely large metal structures of great cost and importance, over time, they will corrode, depending on the environment, but it's just a natural, you know, impact with metal. You know, not everything can be built out of aluminum or stainless steel. The cost would be extremely prohibitive. So what they will do is they basically install an electronic rust inhibitor system, which causes the voltage and the current flow of the metal structure, whether it's a water tower or a pipeline, the electrons to flow in a certain way. I'm not a chemist, but in such a way that negates the electrolysis that causes corrosion and rust. So it'll extend the lifetime of the equipment significantly. And to do this, you need power, a fairly significant amount, but it's not unachievable. More and more solar systems actually can provide 100% of the energy required for these cathodic protection systems. They're a huge ROI in terms of the costs they save long-term with not having damage or having to replace these pipelines. And they can be done simply by setting up what's called a ground bed and a certain amount of current or voltage potential, very low, but has to be always present on that metal equipment, and it will extend the life considerably. That's, I guess, a rough overview based on what I've seen, and I know it's a very big industry, both in grid systems and utilities as well as off-grid.
Yep, this is a huge application where Morningstar controllers are used, and inhibiting rust protection is extremely important, both on the pipelines and the offshore applications that you saw earlier.
Mhm.
So I believe that takes care of all the questions. Let me just check very quickly to see if there's anything else that came in. I think I did get one here. All right, yeah, this is a good one. In a typical remote powering installation, about how long can you expect the batteries to last?
Well, I would just say a rough number just for conversation's sake. I would expect with a charge controller such as ours that's got temperature compensation, it's going to provide deep battery discharge protection, proper charging, an MPPT that's going to get the maximum efficiency of power into that battery. If you've got those systems in place, I think a well-sized, not undersized system with a lead acid battery should be able to deliver, I'd say 5 to 7 years would be optimal. I think a lot of them fall short, probably because they're lacking in certain areas, or maybe a little bit too much load and a little too little battery. But 3 to 5 years at the very least. I think 5 to 7 in a very well-designed system that has not a lot of deep discharge. And then in cases of lithium batteries, if you just do the math with the number of cycles, you can easily see 10 years or more. Again, when it's been properly sized, so that you're not depleting the battery 100% every single day, because you're going to greatly increase the cycling of those batteries. But I think that's pretty standard. One of the things we're trying to do with a lot of the products is give that feedback so that customers can anticipate when their battery's at end of life, the telltale characteristics of a battery that's sort of on its last leg, how to see that in the data, and know when to replace it. So.
Okay, well, very good. I think you want to go, I guess this is the last slide, the thank you slide as well. And you see our website up there. It looks like we've come to the end of the hour here, so we're going to close things out. I'd like to thank you, Brad. I'd like to thank all the attendees, all the great questions that were asked, and we'll see you next time. And this concludes the broadcast. Thanks so much.
Okay. Thanks, everyone.